For 23, the problem is cars driving and it hydroplanes, and so it's sliding across the ground. It gives you the acceleration, and I believe it wants to know what the force of friction is. Does that sound right? And then for the optional one, it wants you to solve for the coefficient of friction, which we can look at that too for that one. So here is what I want to do. I want you guys to start on it and try it first. Then I'll come around and see if you guys have any completely bewildered looks, and then we'll talk about it together. But a couple of hints on this. Make sure you're drawing a diagram. And for the diagram, you need the forces labeled, the direction of motion labeled, and the acceleration labeled. So make sure you have those things on there. The second thing you'll want to do after the diagram is you'll want to do your knowns and unknowns. Once you've done knowns and unknowns, the next thing you should do is find the net force. There are two ways to do that, so look at your equations at the bottom of your review, and that'll help with that. And then lastly, you're going to solve for whatever it's asking you to solve for. In this case, it wants to find the normal force, not the normal force, friction force acting on the car. So go ahead and see what you get for that one. Do keep in mind there is no applied force on this one. It's only the friction force. I believe there's something about you put your car in neutral to make the problem easier. Yeah, good for you. So anyway, go ahead and see what you can do with that. I'll give you a minute or two to get started. Feel free to talk to your partner and work together on this, and then we will go over them together after I come around, ask some questions. So first of all, we're going to draw the diagram. So here's my car. Okay, so its motion is to the right. That's the velocity. We know it's got a force. Friction, we know, is slowing it down, although barely, but it still is. We said there's no applied force to the right because we put our car in neutral. We got gravity acting down. We got normal force acting up. And then the acceleration is going to be the direction of the rate of change. Since we're slowing down, it's opposite of motion, so A will be backwards. So then we get to knowns and unknowns. For this, the known values are the mass, which is 980. Is that right? Okay. 980 kilograms. We got the acceleration, which is 0.87. Negative 0.87, yes. So the reason it's negative is because we generally make the direction that we're moving positive. That's why we identify it. Which means the acceleration in the opposite direction would need to be negative to show that it's opposite direction. Okay? Then we want to find the net force. There's two ways to find the net force. You can do F net equals ma. Or you can add the forces together. It doesn't matter, but you have to have all the numbers to do it. So, for example, we don't have any of the forces side to side. We don't know the values. So we can't do the F net equals F1 plus F2 plus whatever. We can't do that. But we can do F net equals ma because we know the mass is 980 and we know the acceleration is negative 0.87. Okay, so that value for the net force is negative 852.6. Now we take that and we plug that in for the net force in my other equation. So my net force is negative 852.6 equals force 1, which would be friction, plus any other side-to-side force, which we don't have any, which means the force of friction is the net force this time. Okay, that takes care of part A. For part B, it wants to know about the coefficient of friction. So, the force of friction equals mu Fn. So, force of friction we just found it was negative 852.6. We're solving for the coefficient of friction, which means all we have to know is the normal force. Problem is, it didn't give us the normal force. However, what should the normal force equal? Say again? Almost, really close. It should equal the force of gravity, which is 9.8 times the mass. So, I'm just going to put that in. 980 times the mass, which is our mg, so 980 times 9.8. And when I do that, I get a coefficient of friction of negative 0.8. Sorry, 0.089. There you go. That's how you solve that one. So not too bad once you kind of see it. It's one of those where you kind of expect it to be more complicated than it is, and so sometimes that can throw you off a little bit. But that's what we have for that one. Okay. The coefficient of friction is very small, but it should be. We're hydroplaning. So there is friction, but we're just sliding barely across the surface. So that number makes sense.